I'm ready.
All right, hi guys. Another lesson today. Today we'll talk about energy and rates of reaction. We're going to start off with the energy reaction, and there are two types of reactions regarding energy, really, that we're going to talk about today. There are endothermic reactions and exothermic reactions. We'll start with endothermic reactions, which I already have written up on the board here. Now, when you think about the word endothermic, we want to look at the Latin roots of the word. We've got endo, meaning into or enter, and thermic, which we know refers to energy, whether that's heat energy or another type of energy. We're just talking about energy. So this is energy into the reaction. We can draw a graph of an endothermic reaction. And the graph would be representative of energy over time. The starting energy of the reaction would be somewhere in here. And then as energy is absorbed over time, and then as energy is released over time, and then the ending energy of the new substances that have been created. During any reaction, energy is both absorbed and released. What we're measuring here is which is greater, the absorption or the release of energy. And as you can see here, more energy goes in than comes out of the reaction. And that's why this is an endothermic reaction. Now, you can see that we have a constant beginning and a constant ending rate of reaction, and there's energy at both those. None of them are at zero. So there's always energy held in compounds or in elements. This energy is usually held in the bonds of the compounds or elements. And so we have the starting energy, energy absorbed, energy released, and we can measure that as such. This here would be the activation energy. And we can measure this here, energy gained and energy released. And that's simple enough. So an endothermic reaction is any reaction in which more energy is absorbed than is released in the reaction. We'll skip over and pick up another color here, and we will do exothermic reactions in red. Now, again, we want to look at the Latin roots of the word. We've got exo, meaning to exit or to leave, and thermic, meaning energy. So this is a reaction in which more energy exits than is absorbed. That type of reaction might be written like this. Okay, here we've got the beginning energy and the ending energy, both at constants when the energy is held in the bonds. We've got energy absorbed. We've got energy released. This part here would be the activation energy. And this here would be energy released. And that's simple enough. So we've got endothermic reactions, reactions in which more energy is absorbed than is released. And then exothermic reactions are reactions in which more energy is released than is absorbed. Activation energy here, something that we labeled twice, is the minimum amount of energy required for a reaction to occur. And we won't go much further into that. I do want to talk about 4 things that will increase or decrease the rate of reaction, moving on to rates of reaction. All right, so we've got temperature. Temperature is the first thing. In this, the higher the temperature, the greater the rate of reaction. So the faster the reaction will occur. You say, well, why does this happen? How does temperature affect the rate of reaction? Well, if you recall back to the states of matter several months ago, when we talked about states of matter, the higher the temperature, the faster the particles of the matter are moving. In fact, temperature is simply a measurement of particle movement speed. And so if the particles are moving around at a greater rate, they're going to have more collisions, and collisions with greater force, creating more energy. And that's why it speeds up the reaction, because a lot of the particles already have enough energy to react. The next one we're going to talk about is surface area. And surface area really is quite simple. Basically, the greater the surface area of the reactants, the more particles of that reactant are exposed to each other and to the energy. So the greater the surface area, the more exposure, the faster the reaction is going to occur. One of the ways you can increase the surface area of a reactant is to grind it. So if you grind the reactants into a powder, that increases the surface area and therefore it speeds up the rate of reaction. Concentration is the third. The greater the concentration of the reactant, say in a solution, by definition means there are going to be more particles of the reactants in the solution. And again, the more particles there are exposed to other reactants and to the energy, the faster the rate of reaction is going to occur. And then the last one we'll talk about are inhibitors and catalysts. And they're antithesis of each other. So inhibitors, as the word inhibit applies or implies, means that they are going to inhibit a reaction from occurring. So they're going to slow down or stop a reaction. And then, of course, the opposite, catalyst. Catalysts are things that will speed up a reaction without being consumed. Here they are, they speed up reactions. But generally are not used up, and so can be used again and again as catalysts for reactions. So the four things: temperature, surface area, concentration, and inhibitors or catalysts that can affect the rates of reaction or how fast a reaction occurs. And that's about it. That's our lesson for today. I hope you enjoyed it and learned something. Be sure to study this, the graphs, and your vocabulary. And we'll see you next time in class.